Good day everybody. So today we are doing derivatives of inverse trig functions. So I will just start with the derivative of arcsine of x. So we have y equals to arcsine of x, right? Y equals to arcsine of x. So if we have y equals to arcsine of x, I am trying to remove these arc signs and so on, right? So I can just bring back the sign to the side where there's a y. It will be sine y equals to x. Then after that, I can now do differentiation. I hope you remember implicit differentiation. Implicit differentiation. What do we get if we differentiate sine y with respect to x? So this will be cos y dy dx equals to, then on the right hand side differentiating x we get 1. So from this I can now make dy dx subject of formula by dividing everything by cos y. So we have dy dx, we have dy dx equals to 1 over cos y. Okay, so now let me just take you a little backwards. Okay, I hope you remember that cos squared y plus sine squared y equals to 1. That is the mother identity of trigonometry. Cos squared y plus sine squared y equals to 1, right? Sine squared y equals to 1. So we can make cos squared y the subject of the formula. This means that cos squared y will be equals to the square root of 1 minus sine squared y. What did I do there? I just bring the sine squared y to the other side where there's a 1. So we have a plus in the middle, it will be a negative. Then we take square root both sides to find cos y. So this is just cos y, right? This is cos y because we took square root both sides. So the square and the square root will cancel out. Okay, so now what will be my next step? My next step now will be replacing sine squared y with something. So this is equals to the square root of 1 minus. What's now sine squared y? If you look at our step number 2, we said sine y equals to x. So sine squared y will be equals to x squared. We will just square both sides. So sine squared y just same as x squared, right? Okay, so now let's move on and see what we can do. Okay, so now I have my dy dx. So now I have my dy dx equals to 1 over square root of 1 minus x squared. That's my dy dx. Okay, so from today onwards you should know that if you differentiate arcsine of y, you get 1 over the square root of 1 minus x squared. So d dx of arcsine of x, right? Arcsine of x is always equals to 1 over the square root of 1 minus x squared. So we are done with this question. Okay, so let's move on and see what else we can do. Now let's see what's the derivative. Let's now see what's the derivative of arctan of x? So we have y being equals to arctan of x. We have y equals to arctan of x. So we can say, we can bring the tan to the side where there's a y, right? So this will be tan y being equals to x. After that, we can just follow similar steps like what we did in the previous question where we were finding the derivative of arcsine of x. So differentiating tan y is always sec squared, but this is differentiating tan y with respect to x, right? So this will be sec y dy dx being equals to, if you differentiate x with respect to x, it's just 1. Okay, so we can then make dy dx the subject of the formula. We can say dy dx is equals to 1 over sec squared x. Okay, then we can also use another identity for sec squared. I hope you remember that sec squared is just the same as 1 plus tan squared y. This is y, not x. This is y, sec squared y, right? Okay, so this will be equals to 1 over 1 plus. Now let's go back again to our second step where we had tan y equals to x. So it means if we square both sides, it will be tan squared y equals to x squared. So I just replace tan squared y with an x, right? So this will be x squared, and this is our dy dx. So now let's write it finally. So we have d dx, we have d dx of arctan of x, right, is always equals to 1 over 1 plus x squared. Okay, so for this question we are done. So now let's see what's our next question, right? Yeah, so in our next question we are going to find the derivative of arc cos of x. We are going to find the derivative of arc cos of x. So we'll be having y equals to arc cos of x. This is our function that we have, right? Remember, arc cos of x, that's a function again, okay? But right now we are not going to draw or do anything. We are just going to find the derivative of arc cos of x. So I can just bring the arc cos to the side where there's an y, and it becomes a cos without any inverse. Okay, so this will be cos y equals to x. I can now differentiate. That is implicit differentiation. If you differentiate cos, you get negative sign. Since there's a y, it will be y dy dx, because we are differentiating with respect to x. So this is dy dx being equals to 1, because if you differentiate x with respect to x, is just 1. Okay, so making my dy dx of the formula, I divide everything by negative sign. So this will be dy dx equals to negative 1 over sine y. Then after that, I also take, let me just write down this mother identity, sine squared y plus cos squared y always equals to 1. I hope by now you know this by heart. Okay, so now since I have a sine, I want to make sine squared y subject of the formula. So this will be sine squared y equals to 1 minus cos squared y. Okay, so from this I can now say sine y is equals to the square root of 1 minus cos squared y, right? Okay, so let's move on. Now I want you to see again from the second step that sine y will be equals to the square root of 1 minus, we want to say that cos y equals to x squared. It means that if we square both sides, we will get cos squared y equals to x squared. So from in the square root, I'll just replace the cos squared y with an x squared. This will be x squared, right? Then after that, I can now say dy dx is equals to negative 1 over the square root of 1 minus x squared, right? This will be my answer for differentiating arc cos of x. I hope you enjoyed. For more videos like this, subscribe and don't forget to ring the notification bell so that you'll be notified whenever I upload a new video. Thank you. Please comment and share.